Hey guys, this is Mr. Sal. We're going to look at some generalized factoring methods or strategies just for any type of polynomial. Of course, they're based on the ones we've already looked at, so thanks for watching. Don't forget to like, comment, and subscribe.
It's just a general strategy for factoring, okay? It's not required that you do it this way. I mean, if you can factor stuff, there's 3 slides to this. If you can factor a greatest common factor just to start out with, usually it'll simplify things so it's a little bit more aesthetically pleasing, which I think we like. So, if you find some kind of greatest common factor that you can pull out, do that first, okay? If you can't, well, even if you can, you would just move on to part B right there. So now you're looking for any of the forms. I would say look first for the sum or difference of cubes first, which would then allow you to use the formula to factor the stuff out. If not, then hopefully you're looking for factoring by grouping some way. Now we went over the sum and difference of squares as well. No, the difference of squares, which gave us a rule. Not that anyone remembers because of factoring by grouping, but you could use that if you saw it in part B as well. Try factoring as, yeah, that's what that's saying right there. That's good. So this is just talking about if, depending on how many terms there are. If there's 3 terms, look to factor by grouping. If there's 4 terms, look to factor by grouping. That's pretty much all it's saying right there. And always factor completely. So if you guys find that you missed some kind of greatest common factor in the beginning, there should be another greatest common factor that can be factored out from usually one of the sets of parentheses that we're looking at. And that's what this is saying, part D, I think, is, oh, I'm sorry, it's saying that you should check, but usually those become leading terms, the greatest common factors. They're just in front. D is saying to check, which means you're going to have to multiply everything all over again. And since it's so enjoyable, most people, they love doing that. So it's just unfortunate I can only get about 1% of my students to actually do it. All right, this is just to help us limber the mind a little bit. Because, well, things are a little stressful right now because, we're less than halfway through the class. But anyways, I can see that I have a common factor for both of these, that is x minus 9. Maybe it's a set of parentheses. And we've seen that before, right? So in other words, I'm going to pull out from both of these 2 terms an x minus 9. And then whatever else is left, I'll put in its own set of parentheses. So specifically, I'm looking at this 15x, and then this plus 2 right here. So this one that would have been considered step 1. I factored out a greatest common factor. It just happened to be a binomial. And now I would look these over just to see, well, this is another binomial, but it's not a difference of 2 squares. So I can't split that up. And there's no other greatest common factors to pull out from either of these 2 sets of parentheses. So that's it. Okay. Well, same concept on this one. I'm just going to pull out that 19t minus 6. It just looks, sometimes we look at these and we think they're just a little bit more complicated, which complicates the mind, and then we forget just the basic stuff, right? And in this case, I am looking at 2 common factors, 19t minus 6. And then once again, I'm just looking to multiply this by whatever was left over in its own separate set of parentheses. So I've got my 19t there in the front, and then I've got a negative 13. All right, so I mean, you can give this a once over and see if there's any other greatest common factors to pull out from either set of parentheses. I just don't see any. 19 is prime, so is 13. You could pull out a 1, but you'll end up doing that a long time if you keep doing it. So. All right, so if I saw a problem like this and it said to factor, right, I would go through those steps and say, well, I don't see any greatest common factors. Two terms have m's in common, two terms have n's in common, that's great. But that's not really going to help me, and there's no numbers that I can pull out of these. So what I'm going to do is, here I've got an m squared, and the middle term has just a regular m, and the last term has an n squared, but the middle term also has an n. So I don't really have to worry about m's or n's, okay? What I want to do is look at this in the form ax squared plus bx plus c kind of stuff. So I'm going to take the same strategy there in terms of factoring by grouping, okay? Now c in this case would be the -3, and a is just a 1 right there in the front. So I'm really just looking for factors of -3 that are going to add up to -2 in this case. So I'm going to split the 3 up into, I'm going to go with -3 and +1. Because now when I add these two together, I get that -2. So, I don't need this anymore. I'm going to split up the -2mn into -3mn and a +1 mn. We can put the 1 there if we want. Now I've got my leading term, m squared, and my, I guess you could call it a trailing term, 3n squared. And now I'm looking to factor by grouping. So this first set I can factor out an m, which would leave me with m minus 3n. And then the second set I can factor out just an n, which would leave me, oh that's, I apologize, that should be plus between those. Let me clean that up. So I've got m minus 3n, which is what I had in that other set of parentheses. So I can factor that out, and then whatever I got left over, m plus n. Yep, that would be it. This is a good one. Been looking at this, right? Is there any greatest common factors here? Yeah, x. It's just not numbers, so we got to be careful with that as well. If I take an x out of each of these terms, then I'm left with, now I've got 2 x's left over here, 1 left here, and none left on that third term. So x squared plus 5 of these x's minus just 14. Now again, we could check just to make sure, like if we distributed that purple x back into the parentheses, we should get what we started with, and we would. So now I'm looking at, my leading coefficient there for x squared is just 1. So I'm just going to look at c, my c value, which is -14, and try to split this up into two values that add up to +5. It's not a lot of factors for 14. I mean, 1 and 14 is not going to help us, but what about 2 and 7? Yeah, that seems to work. But this is -14, right? So it appears that we want the 2 to be negative and the 7 to be positive, because now when I add those, I do get the +5. And now I'll break up my 5x into -2x and then a +7x. Now, once again, I was looking to factor by grouping specifically because what was inside that set of parentheses was a trinomial. Okay, it had the 3 terms, and factoring by grouping works especially well for polynomials with 3 terms. Okay, so now we're looking at factoring by grouping. So I got my first set there. I'm going to factor out an x, and then in my second set, looks like I can factor out a +7. So now I've got x minus 2, which is what I would expect from the green part there, right? All right, so from that black set of parentheses, I can factor out an x minus 2. And then what do I got left over? I got x and +7 as my answer.
On that second to last row.
All right, a couple things about this one is, if I were to look at this just initially, I'd look at that x cubed and think difference of cubes, right? However, the 100 also has an x, so I know I can factor out from both of those terms an x. But then I may look at the numbers, and I see 4 and 100 are both divisible by 4, right? So that means that I can factor out a 4 from both of them as well. Which leaves me in parentheses there with just an x squared, and then this would be a negative 25 because I pulled that x out as well. All right.
These are perfect squares, right?
Yeah, this is the difference of squares here. So that allows me to use the rule. I've got the 4x in front, and that's good. But the rule indicates that I'm going to split this up. And one of these is going to be minus, the other is going to be plus. I've just got to figure out what my a and b values are. So it's a minus b times a plus b. And no, it does not matter if you switch these around because of the commutative property of multiplication. So right here I can see that this would be x squared and 25 would be 5 squared. This is just so that I can acknowledge what my a and b values are. So a is x and b is 5. Done. But factoring by grouping always requires that we at least start with 3 terms. The third term right now is just unseen, which we talked about last time, right? So in this, I'm going to expand this so that I can see all 3 terms. I automatically have my x squared and my negative 25 terms. But now I'm going to include my 0x's. See, this changes it into the form ax squared plus bx plus c, or in this case minus, if you will. And now I'm looking for factors, right, because that coefficient of x squared is just 1. So I'm looking for factors of negative 25, which will add up to 0. Those are negative 5 and positive 5, which we saw in the answer, right? Of course, if we wanted to factor by grouping, which is what we want right now, I would change the 0x into negative 5x's and then a positive 5x's. Could you switch those around? Yes, you could, because they still add up to 0x's. And this is just regular factoring by grouping, which I think we kind of like. So from this first set, I'm going to factor out an x, which gives me x minus 5. And from the second set, I'll factor out a positive 5, which leaves me with x minus 5. So from those 2 terms inside of this set of black parentheses, I'm just factoring out x minus 5. And then whatever I have left there, which was x plus 5. And we had the 4x out in front. So yeah, if you wanted to, you could use factoring by grouping on these as well. We just have to remember that that 0x is there, that's all, usually. Just looking at this one, once again, to start out, I would look for greatest common factor. I can't factor out a z from all 3 terms. 2 and 4 are even, but 9's not. So I can't even factor out any numbers from all 3 of the terms, which means I'm back to ax squared plus bx plus c stuff. And in this case, my a is 2 and my b is 4. So I'm just going to multiply these 2, which would give me 8. So now I need 2 factors of 8 that will add up to 9, which I'm going to use 8 and 1. So I'm splitting up my 9z into 8z and then a positive 1z. And then from here we're just looking at factoring by grouping. So I'll group these first 2, and it appears I can factor out just a 2z from each of those 2. And I would be left with just a z and then a positive 4. Now my next set, 1z plus 4, I can factor out a 1, which leaves me with z plus 4. And I can factor out my z plus 4 into the front of this thing, z plus 4. And then in this other set of parentheses, I've got my 2z and my plus 1. Looks done to me. Right? No other greatest common factors to pull out of those. No perfect squares, no cubes. Just good old-fashioned factorization. Now, I assume we struggle with this one, especially because the numbers are, well, they're bigger than we're used to, right? And that's okay. That's not a problem. With a calculator, hopefully this would be a little bit easier, hopefully, right? This one's kind of like the one that we did before where it was m and n instead. I'm not so concerned about the x squareds and y squareds as much as I am about the coefficients. So I'm looking at the a value, which is 20, and the b value, which is 54, and I need to multiply those. Actually, before I do that, I should just double check, okay? 20, 69, and 54 have no common factors that I can pull out. So there's not even any greatest common factors here, which kind of stinks. Like, it would have been great if it would have simplified, but again, we can deal with big numbers. So this appears to be 1,080, which is, well, relatively, it's humongous. So what I have is 108 times 10. I'm just looking at that because of the last number there. The ones digits was 0, no good. I know 108 is divisible by 12 though, so let's see if that helps. 12 and 90. That doesn't give us any help right there either. So let's take this even further. Maybe 36 and 30. Nope. When I combine those, it'd be 66, but that means I've gone too far. Yeah, when we combine those, we get 69, and when we multiply them, we get 1,080. Now, the number we really want there is negative 69, so we're just going to make both these negative. Here. So I'm going to break my negative 69xy into negative 45xy and negative 24xy. Now we're just looking at factoring by grouping. So 45 and 20 have factors of 5. Yeah, 15 is not going to help us. So I'm just going to factor out a 5 and an x, which would leave me with 4x minus 9y. And then in this other set of parentheses, we'll make that plus negative 24 right there. I'm going to factor out, it's going to be negative, whatever it is, and it appears it's going to be a negative 6y. And that leaves me with 4x minus 9y. Alright, so I can pull out of those a 4x minus 9y. And I've got in this other set of parentheses, there's that, the 5x and the negative 6y. That's it. Yeah, I can't factor out anything else from those. So I would be careful on this. You could factor this regularly and it would be great, okay? But what I'm doing here is I'm looking for perfect squares, and that comes with some time, right? Again, it's not required that you do this way, but I see that 25x squared is a perfect square, and so is 16. So I mean, it looks like I'd be looking at the difference of squares, square of differences, whatever. Is that how you guys want me to do it, or just factor by grouping? Yeah?
I want to see the squares.
Just use the rule? Okay. So to do that, hopefully remember from class, 25x squared is 5x, which is squared. So that gives me some kind of a value. And then the b value here, 16, would be 4 squared. Now when this happens for a trinomial like this, I need to look at that middle term and make sure that, in this case, right, we're looking at negative 2ab plus that b squared rather. So if I replace a with 5x and then b with 4, does that give me that negative 40x, which is what I'm looking for? Well, let's evaluate that middle term. So 2 times 5 times 4 would be 40x. So ultimately, I ended up with that negative 40x middle term anyways, right, because this was minus here. So negative 40x indicates that we can go to the rule, right, that was a minus b squared. And in this case, a is 5x and b is 4. Done. Well, we just got finished with some of these, right? In 4.6. W cubed is perfect cube because it's cubed. And 64 is 4 cubed. So, we'll just acknowledge this W cubed and 64. I'll put that in a different color. So this is the difference of cubes. So let's go and write our formula out, right? Keep the sign in that first one. SOAP, right? So stays, opposite, always positive. And this is a minus b, a squared plus ab plus b squared. So we do have our a value, which is w, and our b values are 4. So the only thing left to do is to multiply w and 4 squared. And 4 squared is 16. That's it. Well, we can do this by substitution, which is kind of what we did earlier with that it was 64, the one we just looked at with the x to the 6th and y to the 6th stuff. But we're replacing a's and b's. Well, actually, usually it's sometimes the x squareds with, x to some power with just x squareds, which means we got to figure out what x is as well. We just also, and that's a common mistake there at the bottom. I see it all the time on tests, where we forget to replace whatever we substituted back into the final, I guess, factored expression. That's a big deal, right? Because it usually requires some more work. Well, this one's not really an ax squared plus bx plus c stuff. But here's what's nice is I can see that this is kind of like a difference of squares stuff. Because it only gave us 2 terms. So I should be looking for something like that, if not a difference of cubes stuff. But x to the 4th isn't, 4 is not divisible by 3 really. So I'm looking to make this some kind of squared value. And the 16 as well. I want that to be some value squared as well. Okay. So that means that I don't really need substitution on this one. Didn't really pan out that way, and that's alright. But x to the 4th would be x squared squared, which we have seen. And 16 would be 4 squared. Right? So in the formula, this is the difference of squares, so I've got subtraction and addition. And my a value is x squared, while my b value is 4. And that's pretty good. Could we factor out both of these? Yes. But right now we only need to factor out one of them, and that's the difference of 2 perfect squares. That's that first set of parentheses. Which means I can replace now this would be the same as x squared, and the 4 is really 2 squared. Right, so I mean, we did it twice. And this sets up a new set of parentheses with the same thing, minus and plus. And my a is x, and my b is 2. Now that other set of parentheses, right now there's nothing we can do with it, even though later on we will be able to. But that's my answer right there. I was looking more for this when we looked at that rule. So we got x to the 6th and then x cubed. But remember, the form that we really want on this is ax squared plus bx plus c, right? I'm not so concerned about the pluses and minuses as much as the x being squared and then just the x to the 1th power as well. So I've got x to the 6th, which is pretty nice. But notice that middle term has x cubed. And what is nice about that is, right, so I got x cubed, but x to the sixth is really that same x cubed, but we've squared it, right? That's equals. This allows us to make the substitution, okay? Because the middle term has essentially, I guess you could say it's the square root of that leading term, x to the sixth, and just with the variable, okay? So in other words, I can switch this now. I can say, instead of using x, I want to use maybe u. It could be using v, I forget. U is good, though. I'm going to say that u is x cubed. Then if I had u squared, that would be x to the sixth. Because it's just x cubed squared, which is x to the sixth, which we've seen in purple there. I can't forget to replace them back into the factored form once I get to that point. But yeah, I'm looking to replace x to the sixth with u squared, and then u cubed with just u, right? The rest of it stays the same. And now I have a new equation representing the old one, but in the form ax squared plus bx plus c. A is just 1, but whatever. So I mean, it really begs the question in this part, if you saw x squared minus 4x minus 12, could you factor that? Yeah, we feel pretty comfortable factoring that out, actually. It's just now instead of x's, we see u's, and once we factor it out, we got to put stuff back into the factored form there. So from this, I'm going to use the rule just so we can factor by grouping. What the heck? So I got negative 12, and I need two factors of negative 12 that will add to negative 4. I'm looking at negative 6 and 2 on that. So I'm breaking up negative 4u's into negative 6u's and positive 2u's. Just factoring by grouping now. So from here I can factor out a u. So I've got u minus 6. And it kind of gives me a goal to look for in terms of factoring out that second set, which we're used to, hopefully by now. If I factor out a positive 2, then I've got u minus 6. And factoring out the u minus 6's, all I have left is u plus 2. Okay? We're not finished yet. And here's why, because the u that I had before, right here, u equals x squared, now I need to go back into this and replace those u's. I said x squared, I think. I meant x cubed. I need to replace those with x cubes. Bam. For this problem, I would be looking for, because I have cubes, right, x cubes, I would be looking for the numbers to be perfect cubes as well. In this case, though, 6 and 2 are not, so I can call this one done. Because now we have a binomial squared plus 12 times the same binomial minus 28, all right? So now, when I look to substitute in this one, I'm going to use u and u squared again. So u is usually in the middle term anyways. And instead of distribution on this one and multiplying that 3c plus 6 by itself, I'm just going to replace u as 3c plus 6. Which means u squared would be 3c plus 6, specifically in parentheses, squared. Which allows me now to rewrite this as u squared plus 12 times u minus 28. Okay, well, I got that negative 28, and this one I won't do factoring by grouping, even though we do have time. We'll use the rule on this one. I need two factors of negative 28 that add up to negative 12. I'm sorry, positive 12. So 14 and negative 2. So this ends up breaking up into what have u And U, I had positive 14 and negative 2. But U represents that binomial, right? So I'm going to replace both U's with 3C plus 6, with the rest of it just staying the same. And there's no multiplication of that U, which is actually kind of nice, which allows me now to combine like terms, and 6 and 14. All right, so 6 plus 14. And, well, I don't see any greatest common factors to take out of those. So it looks like that's going to do it.